Initializing.
Hello, it's time to look at another communication protocol other than serial. Serial communication is excellent for sending messages between microcontrollers and computers, but it is slow and only two things can communicate. What we need is a way to communicate faster to many different devices. With the essential components covered, it's time to unlock even more potential from your ESP32S3 training board by exploring the I2c bus and the expansion pins. What is I2c? I2c, short for Inter-Integrated Circuit, and also called I2c, is a simple two-wire communication protocol. It lets your microcontroller talk to many sensors and devices using just two pins: SDA data line, SCL clock line. With I2c, you can connect displays, more sensors, memory chips, and even advanced AI modules all at once. Here's the kicker. You only need two I/O pins and can connect up to 128 sensors and other components to those two pins. For this to work, your sensors and components must support the I2c protocol. All I2c supported components have an identifying ID. When you, for example, ask for the value of a temperature sensor, you send this identifying ID with your message over the two wires, and the temperature sensor will understand the request and return the temperature value. On the board, you will also find expansion pins. Alongside the labeled main pins, your board exposes extra pins called expansion IOs: IO17, IO18, IO35, IO36, and more. These are for attaching even more hardware as your skills and ambitions grow: motors, extra LEDs, additional sensors, and more. Expansion pins become very useful when you work with breadboards. You can connect wires from a microcontroller's expansion pins to a breadboard. A breadboard allows you to connect components to it without soldering, enabling you to quickly prototype and reuse your components. Now it's time to unlock one of the most powerful features on your ESP32S3, the ability to create smooth, real-world effects using PWM. What is PWM? PWM stands for Pulse Width Modulation. It's a way for your board to mimic analog output using digital pulses. Instead of just on or off, PWM rapidly switches a pin between high and low, thousands of times per second. By changing the ratio of on time to off time, you control the average power delivered. For example, if you switch a pin thousands of times but 50% of the time it is high and 50% of the time it is low, the pin will output 50% of 3.3 volts. That will be 1.65 volts. If it is 75% on and 25% off, the output on the pin will be 2.47 volts. What does this mean in practice? Dimming an LED. PWM can smoothly fade a light from dark to bright. Controlling a motor. PWM adjusts the speed of a fan or robot wheel just by tweaking code. Creating sound. Buzzer tones and music are made possible using PWM signals. Why is PWM so powerful on the ESP32S3? The ESP32S3 can generate PWM signals on almost every output pin, way more than older boards like Arduino Uno. It supports high-frequency, high-resolution PWM, so lights are smoother, motors quieter, and sounds clearer. You can control multiple effects at once, like making LEDs pulsate to music or mixing lights for smart color.
Initializing.